Folks, so I have a pretty cool, pretty awesome MacBook Air repair hack upgrade that I'm going to show you today. And I'm going to show you kind of a rundown of how to repair MacBook motherboards Louis Rossman style. For those that don't know, Louis Rossman has a video channel and is quite popular showing some really cool repairs. I'm definitely grateful to him for showing me repairs. Even though his style isn't for everyone, he does share a tremendous amount of free information for folks, and this video is sort of piggybacking off some of that in a similar style. First note, though, I just want to say you are all probably, like me, very tired of the YouTube ads. There's a ton of advertising pushed in our face right now, and their new terms of service that was just updated this past month is now going to add ads to all of my videos, even though all of my videos are free and I don't want them to have ads, and I make no money off them. I'm a little bit annoyed by that because I want my videos to be without ads and to be freely available. So I'm considering moving to Vimeo for at least some of my repair videos. Let me know if you have suggestions, or if you think I should set up a tipping service or something like that. Though I would prefer to keep everything free and just get rid of the ads. And the only way I know to do that is to post on Vimeo. Vimeo does have limits, though. You can only upload like basically one video a week, which is pretty hard because I do quite a number of uploads. But anyway, on to the repair. So as you heard with the chime, this MacBook Air will turn on when I plug it in. For those that don't know, any MacBook Pro of this generation, this kind of era, which is like the 2009 to kind of 2015 era, will automatically turn on if you plug it in without a battery. It'll just boot. And that's all fine and dandy, but I'll show you where the problem comes in. I'm going to go ahead and shut this down. Yes. And let me show you first, though, before I shut it down, that all of the keys on the keyboard appear to work. I'm going to just go in this notepad application here, and I can zoom in here, I guess. Why not? I'm just going to show you that, everything on this keyboard seems to work fine, including the keyboard brightness setting and the screen backlight. So the FN keys all seem to work as well. There's only one key that seems to not work, and I'll show you that in a second. So go ahead and shut this down. And I'm going to be walking you through schematics, board view, everything in this video. So really cool stuff to come along. But I am going to go by step, so there might be some rehash for folks that are pretty good at laptop repair. So be patient, please. And what I'm going to show you here is the power button does not work. That's a problem, folks. You can't just, you could leave the battery out of this and just unplug and plug in the power cable for it to boot every time. But I wanted a working power plug, and I wanted a battery that also works. If you do that, of course, the battery, you have to take out the battery. Can't use it. So that's a problem. Kind of a strange thing. Doesn't happen super often. Usually when a keyboard breaks, number of keys fail. But in this case, it's only the power key. Now, for those that don't already know, replacing a keyboard on a MacBook Pro, MacBook Air is a nightmare. It's so awful. You have to take out absolutely everything from inside the unit. And then you have to do something like 60 really tiny screws along the perimeter, 60. And then there's a bunch of pop rivets you rip out as well. And Louis Rossman has a video where he shows you this. I've done them before. It's heinous. In my opinion, Apple did this on purpose because keyboard failures are one of the most common problems, and they want you to buy a new computer. They don't want you repairing stuff. So in the case of this computer, it's pretty old. It's an i5, 2011, mid-2011. And 4 gigabytes of RAM. It's nothing like super exciting, 128 gigabyte solid state drive. But it's still a decent computer, especially for like writing code or something. And I didn't want to just, throw it out. So what did I do? Came up with a little hack, a little trick. Check this out. Hold down Shift and hold down Option. And you will hear it in just a second. Ta-da! It now boots up that way. Also, for those that don't know, the SMC reset, which is kind of like resets the BIOS settings, is when you hold down Power and then Control, Option, Shift. By doing it this way, if you hold down those three keys, you can also do an SMC reset, as well as the typical Option, PR, video RAM reset. There's a little trick, and there is a little circuit that I built, and some troubleshooting information I went through to figure this little hack out. So I'm going to show that to you all, and you can follow along. I'm going to show you all the websites you go to, how to get all the files for free, and how to do these repairs. Again, I learned this from Louis Rossman, from folks in the Bad Caps forums, and from Apple-Schematics.se. These are all really helpful resources that I will go over. But first, I want to show you the inside and what the physical circuit that I built looks like, just as a quick rundown, before we jump into the actual schematics and everything, and how I got there. And I will also put stuff under the microscope as well. So first, I usually put a little piece of tape here just to remind me of what kind of MacBook this is. First, I want to show you step by step. I'm not going to go through all the steps, but I want to explain step by step what you need to do to get to this stage. So first off, you need to have a special screwdriver to undo the screws on the outside. They are star screws, but they are a special sized star screw, which you need basically a driver that's made specifically for MacBook Airs. It's totally annoying, but once you get that screwdriver, you'll be good to go for any MacBook Air repairs. Once you get this case off, there's the battery, and the battery has screws in the corners as well as a screw in the middle. You take those all out, and then you're going to take this little clear tab here and unplug the battery. There's also really excellent guides for this step-by-step on iFixit, the website iFixit, and other places around the internet, so I'm not going to go into too much detail there. Once you take out the battery, you will have access to the trackpad, and there will be a barcode here with a serial number. That serial number can be put into a website, everymac.com, and there's other websites that let you put in the serial number to find out the exact make and model of your laptop. This is really important because everything you do is going to be based on the make and model of this laptop, especially the motherboard that we're going to be working with. And I'll go into why that's important in just a second. And so you'll see here, I built a little circuit, and there's these red wires running down here, and I'll explain all that in just a minute and why I did that. And I'll put it under the microscope, and we'll kind of get more into it. So first off, I just wanted to show you how to get that serial number, and also the other important identifying information that you'll need. So I'm going to go ahead and switch over to the monitor here. Sorry, I don't have like a capture software stream that I can stream directly from the monitor, so you'll have to settle for this movement of the camera on the tripod. But it's free. So what you'll do is you can look online. Once you know the make and model of your motherboard, you can search it. And in the case of mine, it's a mid-2011 MacBook Air. And by the way to look that up is you can go up here to everymac.com, and then you can there's a lookup for you can enter your Mac or Apple device identifier. You can go to your favorite search engine or whatever search engine you want to use, and you can look up Mac serial number, and there you go. Look up Mac specs by serial number. You put in that device identifier, it'll give you the exact make and model of your MacBook. So that's the first thing you want to do. Then what you want to do is use that information to look up what the motherboard looks like, or you can check out the motherboard yourself. I'm going to show you a picture of the motherboard. This is what it looks like before my circuit was installed. And if you look really closely, what you'll find, and it's hard to see, so you have to use a magnifying glass sometimes, a printed number like this. And it has to be fairly large. So this print right here is kind of the factory print for the motherboard. But this is, just for like the materials used. This is the actual name, the catalog number, if you will, of the motherboard that is used on this mid-2012 MacBook Air. This number is like gold. It's really great if you can get it. Sometimes you do have to take the motherboard out. I'm not going to show too much information on that. If I have time at the end, I might show some areas to be careful, but there's going to be lots of guides on that online. So once you get this number, then what you're going to look for are schematics and a board view. The board view lets you access the location of every part and the name that's tied to it. And you're going to look for that, again, just in a search engine. So what we're going to do is we're going to take that number, which it says here 820-3023. The A is not that important. 820-3023. And you can put the A there if you want as well. Whoops, I should probably put that it's a MacBook and Schematic. And what you'll find is there are various sites, and here's one that's quite excellent called Apple-Schematic.se, which will pull up your motherboard revision. And this one I've already pulled up in another tab from Apple-Schematic.se, and you'll see it has the board view file and the PDF file. Now these are internal Apple documents that have been leaked on the internet, and you can find them for a lot of older Apple products, MacBooks and stuff, which I think is super, super cool. And, you know, I don't feel guilty about that at all because Apple grossly overcharges for repair for these machines and tries to lock in everything as much as possible, which is really unfair. And this laptop would go in the trash if it wasn't for these kind of documents, because it's not worth paying the money to fix this, to go to the Apple store. It's well out of warranty. So what you do is you click on these two links and they'll take you to you know, a site where you can download them. In this case, it's the Mega Downloader. And you'll say, you know, agree or don't agree to cookies or whatever. And then you just hit download. And there's the board view and the schematic. Once you have those downloaded, and I've already got them downloaded in a folder here, you can open it up and you'll see this is a huge schematic with absolutely everything, almost everything you could ever want to know about how this motherboard works and which parts there are. It's really good stuff. What I'm going to do is bring your attention here to page 3, to the block diagram, which is the overall architecture of the system. And this is a good place to start if you have kind of a rough idea of what your problem might be, or what the computer's problem might be. And way over here, you'll see there's a power button, and it says PWR button, and it's an image of a button that connects ground to the SMC. The SMC, I think, is System Management Controller, something like that. And it's sort of like the BIOS management system, which is sort of the code that runs before you load your operating system. And so if this power button doesn't trigger that, then nothing turns on. So we need to make sure that this is somehow working. Well, we're already suspicious that there's either a problem with the circuitry here or a problem with the keyboard. I at first was very much suspicious of a problem of the circuitry because it's pretty uncommon for a keyboard for a single key to fail. But what we're going to do is we're going to see what actually happens with this circuitry. So we go to SMC on off, and we put in the search here up here, and we see where it shows up in all of these 75 pages. Okay, here is a IPD flex connector. Okay, that's going to be the connector coming from, you know, the keyboard. But one thing I'm going to bring to your attention here is you'll see this is the keyboard here. Keyboard has a connector here, which plugs into this circuit board, which is for your trackpad and your keyboard. And then it comes out of that through this cable to your main motherboard. So this main cable here is the IPD flex connector. This is J5700 is this connector here. I'll show you in a minute how I know that. But what's important is the schematics we're looking at right now are for this motherboard. They do not include the keyboard here or the circuits that are on this board or the trackpad. They only include this motherboard. So when we're talking about that signal, we're talking about it coming from here. So we'll go back up and look at the monitor again. Try to focus the camera here. Sorry, let's see if I can get the focus working. Come on. Come on. There we go. Just had to put my hand in front of it. So yeah, we'll see that this we'll see is in a second we'll find out what this is. And I could actually jump there now. So the other thing that you're going to need, I'll go ahead and jump there now. It's going to need some software called Open Board View. This is a free software. It's licensed by MIT, which is pretty cool. Open source, and you just download whatever operating system version you want it for. And it's just an executable file. There's nothing else there. And it looks like this. This is the older version I'm going to boot up here. You open it up, and it's just, there you go. That's all you get. It's really basic. This software completely rules, and I'll show you why. Because now you can take that .brd file, which is the one we downloaded from Apple-Schematics.se, this BRD board view file, the one that we downloaded. We're going to go ahead and all we need to do is drag that into Open Board View, and voila, we got a motherboard here represented, which is pretty cool. It's a little bit upside down and reversed, so I'm going to center click to flip it upside down, and then I'm going to rotate it. And so now it matches the orientation that we're looking at our MacBook Air. So we go over here and we look at that plug coming from the keyboard area, from the trackpad. We click on it and look at that. It says J5700. J5700. And if we look down here, we'll see pin 11 is our SMC on or off L, which, as I showed, goes to the power button. So that's pretty cool. If you press escape at any time, by the way, you can get rid of those signals that pop up. But we'll start with that. So we got J5700, all right, J5700. And this has our signal. Okay, so that's where it kind of comes from. Let's see what else it goes to once it gets to the motherboard. So once it gets to the motherboard, it does go to our giant chip here. This looks like the SMC chip. This is a giant controller chip. So okay, so this could be a problem. This could be broken or not. What else does it go to? And then it goes here to the SMC reset button supervisor and AV ref. That's analog voltage reference supply. And this is, as it says, the SMC reset. So like I was explaining before, if you want to reset your BIOS settings, most people know that do Apple repair, before you open anything up, you try to just reset the SMC by holding down power, control, option, and shift while supply is plugged in, power supply. If you do that, it resets the SMC. And so that's what this circuit handles. And you'll see here that our SMC on or off L goes there, as does this trackpad reset L, which goes there. And you'll see here that it says MR1 and MR2 must both be low to cause a manual reset, used on mobile devices to support SMC reset via keyboard, which is exactly what I just described. So you want to be able to hold down those keys to trigger a reset. But what it's letting you know is that both of these have to be low in order to trigger a reset. And as we're trying to find out if this actually goes low, if it's our keyboard issue or something else. But this is a good thing to note for the future. And also note that this L seems to indicate low. That's unusual for a schematic. Normally it's an exclamation mark in the front or a number sign that indicates an active low, as in it's active when it's grounded. But in this case, Apple decided to just put the letter L at the end of the name. Cool, that's fine. Nothing here is really important except that it spits out a reset signal at the end of this. So we've got that. Okay, what else does our power button kind of signal go to? Also goes through a 10K resistor, which is clearly a pull-up resistor to the 3.3 volt line. There's a bunch of 3.3 volt lines in here, and this is PP3V3S5, which means it's probably fifth in line to be booted up from some of the other ones. Okay, so there's a pull-up resistor. That's not unexpected. And now it goes to this. Well, this is pretty interesting. The debug power buttons. Okay. Says here omit, which means these parts are not actually placed, R5016, R5015. Let's put these in our board view software because we're trying to test the power button, and that's what this is for, debugging the power button. Okay, let's put this in and see where that goes. R5016, I did Control F and then I just put it in, copy paste. Okay, let's click on that, and voila. One of them goes there. Okay, let's see where the other one goes. That's on the back of the board. That's going to be harder to get to. Let's see if there's something on the top of the board. $5016. Is that the one I already put in? Yeah, I'm trying to put in the other one. 5015. So 5015. Voila, look at that. It's right above our J5700 connector. That's super convenient. That means we don't have to take out the motherboard and flip it all around. Not yet, anyway. Hopefully not. So that's really easy. That's right there. And this, you can also look up on the internet, is actually the 2 points that you can short to make the laptop turn on. and which is why they call it the debug power quote buttons. Really, they're not buttons, they're test pads that you can short with a pair of tweezers or a piece of wire that will turn on the laptop. And that is a way to check, how to get the laptop turned on if your keyboard's broken or your power button's broken. So, spoiler alert, I already did this, and the laptop turned on just fine. That's how I knew that nothing major was damaged on the motherboard, but that there was an issue with the keyboard or with that trackpad circuit that sort of routes the keyboard to the motherboard. So this is super useful to know whenever you have a MacBook that you're repairing. Look for the debug power buttons, as they're called, and you can use that to test all sorts of to do initial diagnostics. So what else? Well, what else does this go to? Well, it also goes to a capacitor, pull down capacitor, probably for a debouncing. Not really a big deal. It's a high impedance thing. And then here we have it seeing that it comes from J5700, which we saw in the board view. And so again, like we noticed in the board view, J5700 is pin 11. So again, just to point out what we're talking about here, we're talking about this connector right here. And so what we don't have access to yet is what's going on down here, if there's a problem here. But we know once it hits this connector, everything's fine, because you can short the two pins, not my circuit, but the other two pins, and everything works fine. Okay, so we got that all figured out. Now what? Well, we want to find out at this point what's going on before it reaches that connector, where the problem is. I'm going to go ahead and put my hand in front here so it can refocus. All right, get you a clear image. And we want to figure out what's going on. But as you can tell, we don't have access to the trackpad. We only have the board view for the actual motherboard, the main motherboard. So I'm going to show you a little trick, a little workaround. I did actually look up on the internet to see if there was access to the trackpad. And you'll see here, Louis Rossman has his own website. Pretty cool. And it says Macbook Air, trackpad, and audio board question. And everything I found online just said nothing available. There's no schematics, no board view for the trackpad. Well, that's kind of a bummer, because we're trying to rule out the trackpad as the problem. What can we do? Well, let's go ahead. I'll walk you through it. I actually already knew this from previous repair, but I'll walk you through it under my microscope here. I'm going to go ahead and switch to my microscope. Get rid of one of these, make a little bit of space on my desk here. And I'm going to put the motherboard under the microscope where the trackpad is. And we're going to look at the chip, the largest chip that's under that trackpad, and kind of get a rundown of what's going on. So right now I'm looking at the cable from the actual keyboard, and we'll see here this is the trackpad PCB that we're trying to find a problem. You'll see my repair hack over there, and if I move this cable, this connector right here is where the keyboard gets connected. Okay, we got that. It's pretty basic. What we want to figure out though is what this circuit board is doing before it sends that signal to the main motherboard. Well, primarily what it's doing is it's converting the parallel interface of this keyboard into a serial interface. Parallel means you have like a bunch more buttons basically, and you're trying to make it send that data in just 2 wires instead of like 20. And it's doing that conversion. That's an oversimplification, but that's basically what we're trying to figure out, how it's doing that. Because if we can find out how it's converting that keyboard data, what chip is doing that, then we can get closer and closer to finding out where the fault is. And so we see here that there's a chip that is labeled the CY8C2479, which is that chip right there. And that's the biggest chip on this board. And if you kind of just generally look at the data lines, they look like they're going towards the keyboard, though this is a little bit of trial and error and knowing the hardware. But this connector right here, for example, this is coming from the trackpad. So my guess is it's like, oh yeah, this chip is probably going to be used for the trackpad. And over here, this is another trackpad connection. And, I would guess maybe that this is related to the trackpad as well, though I'm not 100% sure. But I know from experience and from looking at other schematics and just from sort of deduction that this handles the keyboard. Okay, so CY8C247. Well, if you do a little bit of research, which I've already done, that chip is used in all MacBooks of this generation. Apple didn't go crazy and redesign the keyboard interface with every single MacBook they put out. And so the mid-2012 MacBook Pro, not the Air, mind you, this is the Pro, has that chip. In fact, the MacBook Pros do not have that circuit board separate on the trackpad. It's actually incorporated into the main motherboard. So what we can do is get ourselves a 2012 13-inch board view and schematic, as you can see on the same website we used before. And we're going to open up the schematic. And I have my notes here, which page stuff is on. I think it's on page 53. And you can search that same signal, that SMC on-off low, see where it goes. And we'll find, voila, we have a keyboard connector. Well, this is really helpful because the keyboard connector is most likely going to be standardized. And it's going to go to that same chip. And if we look up that chip, I'm already forgetting the name, CY, there it is, the USB controller. And you'll see here, KBD stands for keyboard. There's all these friggin' keyboard inputs everywhere. And this is also on page 53. And so that's our same controller chip. And then here's our keyboard. Well, what do we got going on with this keyboard? Fortunately for us, all these KBD, these are all parallel interface that needs to be converted to serial. Fortunately for us, there's a few keys that don't get converted. And that is our on-off low, which we know it should just be like a button basically. Our left shift, left option, and our control, as well as caps and number. Well, that kind of makes sense if you think about it. Because if these 4 keys are used to reset the SMC, well then it kind of makes sense that they wouldn't go through a bunch of circuitry. And of course we saw in the very beginning, the block diagram, that keyboard on and off was just a button. Well, that block diagram simplified a little bit. There actually is a 1 kilo ohm resistor between keyboard on and off L. Okay, so we know there's a 1 kilo ohm resistor coming from the on and off signal, which then goes to pin 5 of the actual keyboard connector. Then it turns into our special SMC on or off L. Hopefully you're all following me here. We know that this works once it gets to the motherboard because it's connected to those jumper pins. And if I short those jumper pins, everything turns on. So we know that this one's fine once it reaches the motherboard. So we know that our problem now, since this doesn't go to the fancy controller chip, doesn't handle that at all, we know that the problem is going to be somewhere in here. It could be this resistor, a broken trace, or the keyboard. Let's go ahead and go back to the microscope and let's take a look at that. So I'm going to get my multimeter probes. I have the needlepoint multimeter probes that Louis Rossman recommends and are super useful. Basically a must-have. They're these very fine-pointed probes that you can get for $10. They're very cheap, but they're absolutely necessary. And so what I ended up doing, I'm not going to do all of this on camera right now, but what I ended up doing is, we know it was pin 5, right? From what we just looked at. So if you look over here, this is actually just a pin that's kind of holding the connector in place. But you count 1, 2, 3, 4, 5, okay? And then you put another pin on ground, which you could just connect it there if you want. And then using some dexterity, you can also get some clip, some alligator clip type adapters and stuff if you want. But I just used a little bit of dexterity, held this down, with my arm or something, held the ground down, and then held the other probe to pin 5 and pressed the power button. Additionally, if you have someone that can help you, to go ahead and refocus the camera. If you have somebody that can help you in this, of course, that would also make life easier. But yeah, so basically you want to get your probes on pin 5 and ground and press that power button and see if anything changes. In the you can either do a beep test with your multimeter or you can do an ohms test. And I tried it to ground. I also tried it to 3 volts. What did I find? Nada. Nothing happened. That's how I knew the problem was the keyboard. And by the way, that 1 kilo ohm resistor with the little capacitor is right here. That's what this guy is, right there. So for all you MacBook Air repair folks, if you're ever looking for that power resistor, it's right there. So this resistor could potentially go bad, although that's pretty unlikely. And when I measured it, it was totally fine. But this side of the resistor goes to those test point pads, and this side goes to the keyboard. That's it. It's almost a direct shot to the keyboard. There's just a 1 kilo ohm resistor. So after doing this, I now know that the problem is the actual physical keyboard is broken. Damn. Not great. I don't want to replace that keyboard. I don't want to pay for it, don't want to install it, don't want to rip out all those screws, don't want to rip out all those pop rivets. It's a nightmare. And a lot of folks might just, I mean, for me, I would just say, forget it. Laptop goes to e-waste, gets donated. I don't care. Not worth it at that point. Maybe sell it for parts. But I wanted to take this a step further. And rather than just replace parts, I wanted to use put on my hacking hat, my thinking cap, and come up with an alternative solution. Let's go back to our schematic and I'll show you what I thought of. So we're going to go to our actual logic board here. And so we know that, yes, this one gets shorted to ground, and we know this is broken. But we know that these keys all still work. Left shift, left option, and control. How do I know they work? Well, one is I've used them, in the operating system. But also you can take measurements. And here's the interesting thing I found. So there's a 3.42 voltage here, PP 3 volt 42 G3 hot trackpad. Keep in mind it's trackpad. You can't just grab any PP3 V42 G3 hot. This is the trackpad one. And that goes to pin 4 right next to it. So that's a 3.4 volt positive voltage. And we know that the keyboard shorts to ground, but what I found out that's quite interesting is all the other keys are active high. They actually are activated when you short them to the 3.42 voltage. Pretty interesting, slightly unusual. And that's why this L is really important. So the rest of these keys are actually activated when they're high. So if you want to test them to see if they work, you put one probe on pin 4 or to another point of this signal, and then you put the other pin on the signal you want to check, and you press down on the keyboard. What you'll find is you'll get about a 200 ohm short when the key is pressed. When it's not pressed, you'll get about 33 kilo ohms because there's a pull-up resistor. I'm sorry, pull-down resistor. You'll get 33 kilo ohms to ground, and you'll get like an open circuit, more or less. I'm sorry, no, I take that back. It is a pull-up. I think it is a pull-up resistor, and it's 33 kilo ohms to high voltage. Anyway, it'll be an open circuit, more or less, when you release the button. So that's how you can test these buttons. And don't forget, that's only for the buttons that don't go to the parallel controller chip, which is this guy over here. So, okay, we know that those just short to positive voltage now. We know that they're not parallel data that gets converted into serial. We know that it's basically like dumb button presses. And we know that they go high, whereas the power button goes low. So then we look over here on the same page, and we'll find the SMC manual reset and isolation. Aha. What does this do? Well, this takes 3 of those signals. Notice that the power button is not here. Puts them through, this is a buffer. It's actually an inverter. They left out the little circle, but it's actually an inverter. Inverts them, sends them into a NAND gate. This is a simple logic gate. Inverts it again, and then spits it back out as SMC trackpad reset low. And then, of course, the keys that you're using for other features in your, when you have your operating system running. Does anybody remember where this came from? Sound familiar? Copy, Control Find, paste. Oh yeah, that went to our SMC reset. That's the second signal that has to be held low to reset the SMC per this note here. Okay, so that's how it makes the other low signal, and we know that this low signal doesn't work. So here's a little trick. What if we could take, instead of 3 of these being held down, just 2 of them held down to create our SMC on-off low. Aha. Then we would have a working power button and we could do SMC reset. How do we accomplish that? Well, as we saw here, actually shows us it's really just a NAND gate, which is to say you only get a high voltage output. Actually, I'm going to screw this up. I'm going to go ahead and open up the NAND. So a 74HC00 is a quad input NAND gate. And you'll see here the schematic symbol is the same as what we just saw, this little deal. If you don't know a lot about Boolean logic and functions and all that kind of stuff, there's some cool sites. You can look it up. Intro to Boolean Logic. There's a really cool site, if I can remember it. Let's see if I can find it. All About Circuits is a good one, but there's one from an actual university that I actually prefer. I think it might be, nope, it's not that one. But anyway, there's a bunch of these things where you can look up Boolean logic gates and they'll explain to you, hopefully keeping it simple, which this one is not. Some of these are better than others though. I like the ones that just have the symbols and their truth table. And I'm not finding the one that I really like. But, aha, I think this is it. This is it. So ee.surrey.ac.uk is the home page. And this is basic gates and functions. And so you can do is it shows you what the symbol is, what it does, what the symbol is, what it does. And it goes down through all the basic logic symbols. You know, really rudimentary, cool stuff. And so we see here with the NAND gate that if both are low, you get a low. If either one of them is low, you get a low. But if both are high, you will get a high. Go ahead and cover the screen again, let it refocus. And so there's only one situation where you'll actually spit out a logic high. In this case, we're working with that PP3V42, that 3.42 volts. So we'll get that high voltage only if these two conditions are met. Those two conditions are both inputs have to be logic high. Well, we know from the testing the testing I did off camera, that these two pins, or all 3 of these pins, when they're pressed, they short to logic high. So of course they're going to use NAND gates to represent that. So if both of these short to high, then we know we're going to definitely get a logic high output. And that will be our NAND gate. So I went ahead and used some EagleCAD software. See if I have the file here still. Oh, I do. I just drew up a schematic of what I was actually going to do. And actually, before I load that, let me show you the truth table in the actual. So there's a chip called the 74HC00, which is just a bunch of NAND gates. So it'll be perfect for adding this, what we need to add, because we need to add our own NAND gate to make it do what we want. So I'm going to refocus the camera again by putting my hand in front. Camera keeps getting out of whack a bit. Okay. So if we look down here on the truth table, oh, I was looking at the wrong function before on the website. This is an AND gate. We're looking at a NAND gate, which is a NOT, an inverted AND gate. So actually, when both are high, you get a low output, which is actually what we want, because we know those 3 signals, they short to high, but we know our power one shorts to low, so we want to invert it. Alternatively, you could use an AND gate plus an inverter or a NOT gate to accomplish the same thing. If you put an AND gate followed by a NOT gate, that would do the same thing. But if you just get a NAND gate, an AND gate followed by a NOT gate would do the same thing as a NAND gate. And we're going to use a NAND gate, which is a 74HC00, which has been around forever. You can get them for like 2 cents. And we're going to look at our truth table here. I actually already had some on hand, which was very convenient. And so our truth table just shows that if both signals are high, we'll get a low output. And this will be our power on. And we look at the pinout, we can see that 1A and 1B are the inputs, and then 1Y is the output. That circuit then just repeats 4 times. That's all there is to it. So, just for clarity, went ahead and made my own schematic. Real simple. There's just a capacitor. Not really necessary, but it's good to couple your power with your ground. And all the unused inputs are tied to ground, because that's proper practice when you're building logic circuits. Otherwise, you can get weird oscillations and power draw. And we have pin 1, pin 2, left option and left shift for the keyboard, which will then output to our SMC on-off low. It's that simple. Now I just need to build this circuit, and this circuit comes in an SOIC package or a TSSOP. SOIC is bigger and easier to work with, so I have that already. And the pinouts right here, pin 1, 2, and 3, 2 inputs, 1 output, and power and ground. And then the unused inputs will be tied to ground. So let's go back to our microscope. And I'll show you that I built that actual chip, the actual circuit. Really simple. Go ahead and lower the brightness here so you can see it a little better. And yeah, not much more to it. There's, I cut out a little piece of perf board to mount it, and then I put a little insulator of Kapton tape underneath it so I don't short anything out on the motherboard. And then I used a resistor lead to hold it in place to ground. Just grabbed ground from a capacitor there. And so we have our 2 inputs and our output. Our output goes to this is the 2 pins that you short to turn on the power. So we already know that that's what we're looking for. And this is your SMC low. And these 2 are the inputs. Very simple. And then at the top here, I added the power input with a resettable fuse, just for extra care, but you don't really need that. You should have some kind of fuse probably just in case you make a mistake. And then this is a bypass capacitor from power to ground. Ground travels from pin 7 up through this wire to the unused inputs and then to the capacitor. There's actually a little wire right here. So, and then I double checked, triple checked actually, that none of the outputs were shorting to the ground, because they will be high if I'm not using them. Yeah, circuit checked out fine. So the very last thing we need to find out is a good place to grab our our output signals from, like to actually solder them. So if I go back to the schematic, I could solder them directly from the keyboard, but that sucker is real small. And I can show you that. I mean, I did show you that before, but I'll show you real quick again. The keyboard here is just very fine pitch. I mean, if you look at my tweezers, it's almost the tip. The pins are about as thick as the tip of the finest needle nose tweezers I have. It's not going to be too fun to solder, and then it's also underneath our flat flex ribbon cable from the actual keyboard. So I want to find an easier place to solder from. All right, so here we are. We're going to look for these 2 signals, the shift and the option signal. We're going to try to find an easier place to grab them from than the actual keyboard connector, which we know is this big guy, keyboard connector. Pretty self-explanatory, because the soldering is pretty hard there. But we know it goes to that chip at least, this U57, and it says here it's a TQFN. TQFN, and we know it's 6 pins, it looks like. 1, 2, 3, 4. Actually, it's 9 pins. Interesting. But we know it goes to an extra circuit before it actually goes to our motherboard, at least on a MacBook Pro. And so far everything seems to match up with the MacBook Pro. So let's switch back to our microscope. And if we look around here, there's a couple candidates for a chip like that. That's only a few pins. It's not going to be this guy because there's only 3 pins. It's not enough to handle those different functions. It's not going to be a big chip like that. It looks like a power MOSFET actually. And these small ones are good candidates, but if we look at the wires, the traces here, they all go to the trackpad connector. So I don't think it's going to be those guys. This guy is a pretty good candidate, and I did some, beep checks, measurement checks, but none of those went to our keyboard, our shift and our control and our option keys, which are right over here. So, looked over on the other side. Again, we have a repeat, which again shows that these guys are probably for the trackpad. But then we have these 3 chips. And when I was doing my tests, I found out that, yes, in fact, the keyboard goes here, the signals we're looking for. And so one of them is here. There's that 33K resistor that I was talking about, that pull-up resistor for each one of them. And then there is power for that chip, which turns out to be the PP3V3 G3 hot trackpad power signal. So you grab those 3, and that's your power and your 2 inputs. Send them over to our new chip, and you're in business. And you now have a MacBook Air that boots up by holding down those 2 pins. Or sorry, those 2 buttons, by holding down Shift and Option. So yeah, that's pretty much it for this video. Hopefully this was useful and educational for you all. And hopefully this sheds a little bit of light on how to repair a broken power button for a MacBook Air or MacBook Pro. And for those that don't know, if your power button's broken, and I think I mentioned this before, if you plug in the supply, it'll boot up right away. But then once you shut it down, you won't be able to turn it on. So yeah, this has been a little, definitely a little bit of work, but you learn a lot more in the process than just replacing a keyboard, and kind of have a fun little hack to show off. I didn't have to wait for shipping or anything to come in the mail, and didn't have to rip out this keyboard and all the heinous work that goes with it. So as much work as this was, it was probably a couple hours of work. I still preferred it to replacing a keyboard. And yeah, I guess that's it. So hopefully you found this video useful. Check out the Louis Rossman forums, the badcaps.net forums, Apple-Schematics.se. Those are all good resources. And of course the Open Board View software, which is free software from MIT. And big thanks, big thanks to Louis Rossman for his awesome videos, and for the folks that are sharing these documents from Apple for free so that we can repair these old computers. Another one lives. I'm going to go ahead and shut it down, and actually I'll do it later. I'll do some work on it. But yeah, another one lives. 2011 MacBook Air, and hopefully you'll have fun fixing your MacBooks. This is Sega Sonic Fan, signing out.